Hey everybody, Trey here. Welcome back to another forecast discussion. Wasn't planning on doing another video on today's setup, but there are some interesting features at play, and I thought it'd be a pretty good learning experience to go through some of the unique features associated with this event. So, going to do a forecast discussion on today's severe weather threat. We have an enhanced risk out from the SPC level 3 out of 5 from far southwest Illinois into southern Missouri, much of Arkansas, and far northwest Louisiana, with a large slight risk extending all the way up into north central Illinois, back to the west, the Arkansas-Oklahoma border, and down into southeast Texas, including places like Houston, Lufkin, into Louisiana and Mississippi. We have an all hazards threat today. Tornado threat is available for today, 5% area coinciding with that enhanced risk area, damaging winds as well, and large hail. Large hail going to be a pretty significant threat early on, perhaps very large hail. We have a 30% hatched area for significant hail that stretches all the way from that Missouri-Illinois border area down to the south in through Arkansas and northwest Louisiana. So all hazards on the table for today. I do think the main threats are going to be damaging winds and large hail. Large hail will be the main threat initially, with any more discrete convection, maybe a tornado or two, and then damaging winds once storms congeal into alignment. We'll have more on that as we go later on into the video. So let's go ahead and get started. We'll start off, as always, with our water vapor satellite imagery, and you'll see this big, broad swirl here across the center portion of the country. That is our main trough for today's event. That has sparked some convection early on this morning across Missouri and down to the south here across Texas, moving into Louisiana. We actually have a mesoscale discussion out right now for this southern portion of the country. Let me pull up the radar real quick for down in that area. And you'll see we do have some storms ongoing down crossing into Louisiana at the moment. Places like Lake Charles going to be affected here shortly, probably by the time you watch this video. Those are moving off to the east. Isolated severe threat, some damaging winds with those as we go through the morning into southern Louisiana. Farther to the north, we have some storms ongoing as well across Missouri. You see this convection here across central Missouri moving quickly off to the east. And this overnight convection, which was a little bit more numerous several hours ago, that has put out an outflow boundary. You see this fine line here. Let me pause the animation here, and you see this fine line right in here. That is an outflow boundary that is surging southeast across the area. And as we know, outflow boundaries can be pretty significant players in severe weather setups, especially for tornado potential. You will notice that it is surging pretty fast, pretty quickly to the southeast. And it is unclear whether that will stop or not, or just continue off to the southeast quite a bit. Usually, when what you want is an outflow boundary to be a little bit more stalled. But this is moving pretty fast to the southeast, and we're not going to have a robust surface response. Those surface winds out of the south or southeast to oppose the motion of the boundary. So it is unclear where this is going to end up. If it's going to continue well to the south and keep pushing south, which will put the boundary somewhere in central Arkansas, or if it's going to stop here somewhere in northern Arkansas and retreat a little bit up to the north. We'll talk about that a little bit more as we go into our surface data, but there is this outflow boundary in play that we need to keep in mind. So back to our water vapor satellite. Here's our big swirl right there in the central portion of the country. We can see on our upper air maps here, 500 millibars. This is our big old trough that is associated with. Not a ton of flow, not a ton of strong flow surrounding the base of this trough. This is a little bit of a unique setup, a little bit of a weird, wonky setup, and we'll go into the details a little bit more later. We do see some stronger flow on the backside of this trough, and this is going to take on a little bit more of a negative tilt as it ejects a little bit farther off to the east today. But this is going to be a little bit of an interesting setup, as the low-level response has been very muted with this trough. We go down to 850 millibars, and you'll see we have a broad cyclone here centered up into northeast Minnesota with broad 850 millibar troughing down here all the way into Texas. You'll notice the winds on the east side of this 850 millibar trough axis are very, very weak. Our low-level jet across the region is extremely weak, only about 20 to 25, 30 knots here down to the south across Oklahoma into northeast Texas. Very minimal low-level jet across the region. Now, number one, this low-level jet is out of the southwest, and we're going to take a look at some soundings in a second, but there is some drier air that's situated back out here to the southwest. That is going to be pulled in a little bit, it appears. And number two, the low-level shear associated with this weak low-level jet is going to be fairly minimal today. So the tornado threat is going to be a little bit conditional, perhaps going to have to rely on storm interactions, outflow boundary interactions, and so the tornado threat's not going to be as big of a threat today as it might normally be. Given such a muted low-level response, you might expect that we'd see some stronger low-level cyclogenesis here east of the Rockies, but that just hasn't happened. We saw surface cyclogenesis yesterday somewhere here in western Kansas. That has since moved off to the north and somewhat washed out a little bit. Let's take a look at our surface map. Yeah, so you see it's moved off to the east or northeast or southeast, wherever, to the east there. It's just kind of strung out, and we just have this broad surface cyclone with maybe a couple different centers here, all the way up from the Great Lakes states, Wisconsin, Minnesota, down to the south into Texas. Along this frontal boundary, there is a cold front that's situated in here that you do see a wind shift across. You see winds out of the northwest to the east of the boundary, out of the south to the south of the boundary, or to the east of the boundary, excuse me. We'll get a closer view of that as we go into the surface data, but there's not a very concentrated surface low with this particular event, and that is going to play a role in the degree of low-level shear and the overall storm mode that we might see today. It's going to be somewhat messy, somewhat unfavorable for tornadoes given such a weak low-level response. Let's look at our surface data here. Let me refresh to get the most up-to-date data. So you will see we're focused on our southern sector here. Here is our cold front boundary. It's a little bit, the winds across Missouri are a little bit wonky due to that ongoing convection. But we do see, if we start down here into North Texas, that wind shift right here going up into Oklahoma, then into southeast Kansas, and up into Missouri here. So our cold front is roughly situated somewhere in there. Once again, northwesterly winds on the east side, or on the west side of the boundary, southerly winds on the east side of the boundary. You'll notice that the surface flow in the warm sector out here across Arkansas, Oklahoma, into eastern Texas, Louisiana, somewhat calm low-level winds, 5 to 10 knots out here. Not those strong 15, 20 knot winds you might see with a very strong surface low. We just don't have a strong low-level response here associated with this upper trough. So that is going to keep low-level shear at bay today, and thus the tornado threat's not going to be that high today, except where storms may be able to interact with that outflow boundary, pending wherever it ends up. Again, we're not sure how far south that outflow boundary will set up. You do see some of that wind shift there. East of that cold front, where that boundary is situated, you do see easterly winds on the north side of this boundary, southerly winds on the south side of the boundary. That is our outflow boundary right there. It's going to be surging south and southeast over the next several hours. And again, it's not clear whether or not this will stop very quickly at all, if it will keep going. Because once again, if we had a strong surface low here, you'd have this boundary moving south, but you'd also have 20 knots or so of flow, just as an estimation, out of the south or south-southeast, which would oppose the motion of the boundary and therefore allow it to stop somewhere here in northern Arkansas and potentially even retreat as it becomes more diffuse into, say, southern Missouri. That would be a much more favorable situation for any supercells interacting with that boundary producing tornadoes. But if this continues to surge south, this may have implications on perhaps undercutting storms a little bit and not allowing storms to ride along the boundary and produce an enhanced tornado threat. So we're going to have to watch that closely. These outflow boundary situations are always tricky to forecast. Again, you see it here. It's surging southeast pretty quickly, and it doesn't show any signs of stopping soon. But we'll have to watch that very closely throughout the day, as that could become a focus for a little bit greater tornado threat wherever it does end up. So let's take a look at some soundings now. We'll start out at Norman. A couple things spring out right off the bat. This is a fairly loaded gun thermodynamic profile. You see some elevated instability already in place, strong instability. Atop that, very strong elevated mixed layer. The EML, we talk about it every video. That's that layer of warm, dry, well-mixed air that originates on the higher terrain of the desert southwest and western Mexico and gets transported off atop any low-level moisture that's in play out in the plains or the Midwest, and allows instability to build and prohibits storm formation, at least robust storm formation, usually in the early portion of an event, saving the environment for later on. We do see some of those ongoing storms. There is some of that elevated instability, maybe a slight perturbation in the flow that has allowed this morning convection to initiate this morning. But Mostly the warm sector is clear. If we take a look at our visible satellite, you see just those storms into Missouri. Some random cloud cover across southern Arkansas, southern Missouri, northern Arkansas, into eastern Oklahoma, but quite a bit of sunshine back out here, and that is thanks to the cap. And we're still waiting for this next perturbation to come in as the main wave takes on a nice negative tilt later on today. But back to our Norman 12Z sounding. This elevated mixed layer is atop some moisture, but it's very, very shallow. 64 over 64 at the surface at Norman, but you see that moist layer does not extend very far into the vertical at all. It is very, very shallow moisture, and that is always an issue in severe weather setups. You want to see a very deep moist layer, the red line and the green line. The red line is our temperature profile in the atmosphere, green line is our dew point. You want to see those close together, pretty far up into the atmosphere. That allows for a robust low-level moisture profile, allows storms are going to ingest that low level air, and you want that moisture to be feeding these storms. Instead, here we have quite a bit of drier air aloft, almost down to the surface, just atop this very shallow moist layer, and that dry air may wreak havoc in a number of ways. As we've talked about before, if you have a lot of dry air aloft, updrafts are going to be feeding on that air. And if you have an updraft that is going up and you have that dry air being ingested, it can actually pinch off these updrafts and make them a little bit more anemic. That's what we call dry air entrainment. So we'll have to watch that. Could limit, at least initially, the overall robustness of the updrafts. I don't think that's going to be too much of an issue today, as we should have at least decent moisture, perhaps a little bit of an increase in moisture later on. We'll see farther to the south if that's the case. Dallas-Fort Worth, not much better at all. So we may be seeing very shallow moisture here. Here's Springfield. So a little bit better upper level moisture here. We may get some of that drier air to advect in because it's situated out to the southwest. That mid-level flow is out of the southwest, you see here. So we may get some of that drier air to work its way in, but across the target area now, Springfield, Missouri, Topeka, Kansas, a little bit better upper level moisture. You see it at Little Rock as well. So we may not have too much of an issue with dry air entrainment today, but that shallow low level moisture may be an issue in this particular setup, and so we'll have to watch that for sure. Another way that this dry air may have an impact is vertical mixing, and we've talked about vertical mixing before. It's when you have strong heating from the sun, and as we know, warm air rises. So if you have the sun here and it's heating the surface, you're going to have that warm air near the surface rise. But what also happens is you can get a transport of that air that's aloft downward below, and that's what we call vertical mixing. And if you have any drier air aloft here, it can get mixed down to the surface, and you can see surface moisture crater a little bit in the afternoon sometimes when you have strong surface heating. We do have that strong surface heating in play. We do see a lot of sunshine here across the area, so that we're going to have strong surface heating today. Now, this the capping inversion tends to limit vertical mixing, but we do see a little bit of dry air beneath that cap, very strong, I guess, tailing off of the moisture right above the surface. So we may see a little bit of this drier air here just below the exact warm nose there get transported down to the surface, and I would suspect that we will see dew points drop a little bit as we go into the afternoon. Now, didn't really cover this yet, and let me go back to the surface moisture real quick. We see 60s dew points up into northeast Oklahoma, northwest Arkansas, but we don't have very widespread strong moisture across the region yet. We're going to see that transported northward today somewhat, but given the weaker low-level response, not too much. So moisture may be a concern, especially with northern extent here into kind of central to northeast Missouri, southwest Illinois. We may see a little bit higher temperature dew point spreads. And again, those dew points, if we can get those 60s dew points up here into southwest Missouri, which I think we will, 64 dew points or so here at Norman, as we said this morning. If we can get that in there, we may see a little bit of mixing. Those drop down into the low 60s perhaps, and we'll look at some models and how they're handling that in a second to get a bit of a better picture on how the mixing is going to play out. But this could be an issue, something we'll have to watch. Dew points could decrease a little bit. Temperature is going to be up into the 80s. That could heighten those temperature dew point spreads. And as we know, higher temperature dew point spreads, generally above about 20 degrees or so, tend to be a little bit worse for tornado production, tend to promote a little bit more outflow production in storms, and that would make a more damaging wind and large hail threat in the storms today. Let's take a look at our wind profiles here. Effective bulk shear is a little bit on the weak side right now, 30 knots or so at 12Z. Photograph's not super long yet, not very significant mid and upper level shear here. Low level shear is also fairly weak at this point. And again, that's not going to change a whole lot throughout the day. We may see a little bit, maybe some pockets of stronger low level jet as we get maybe localized weak cyclogenesis along that cold frontal boundary as it moves off to the east, especially up into central Missouri, where photographs may be a little bit more enlarged there, and we'll take a look at that in a second with some of the models, but not expecting to see a very robust low-level shear and deep layer shear profile for supercells. Should be definitely adequate for supercells, especially as that trough moves in, the mid-level flow strengthens. We should see deep layer shear increase a little bit, but the low-level shear may remain fairly weak. Again, except perhaps along the outflow boundary, wherever it finishes, if it does finish somewhere and become a little bit more stationary, could be a slightly better low-level shear profile right along that boundary for any storms that interact with it. So let's go ahead and look at some model data. We'll look at the 6Z NAM. The 12Z NAM is not quite in yet, so we will look at the 6Z NAM here, doing this video a little bit early this morning. So here's our trough initialized right there. Moving off to the east, you'll see it takes on a little bit of a negative tilt as we go into the afternoon today. If we were to draw the axis here, it leans a little bit off to the left. That signifies a negative tilt to the trough. Some slightly stronger flow rounding the base of this trough as we go into the afternoon. That should help kind of make a little bit more well-defined, a little bit more mature trough, a little bit more well-defined exit region, stronger defluence aloft. If you were to look at the 250 millibar level, you'd see strong defluence aloft. And so we should have a widespread area of large-scale synoptic scale lift for ascent across this region. And the deep layer shear should strengthen a little bit as this stronger flow impinges into the region. Let's go down to 850 millibars here, and you'll see that our low-level jet doesn't really do much throughout the day. Here's at 12Z right now as we go through the afternoon. Very, very weak low-level jet across the region. 20 to 25 knots, maybe some slight pockets of 30 knots or so in here across northern Arkansas, but in general, the low-level jet is not super strong with this particular cyclone, low-level cyclone, and that is going to have an impact on keeping low-level shear at bay. Again, tornado threat may be reliant on storm interaction and outflow boundary interaction in today's event. And it stays fairly weak through about sunset, does pick up a little bit going into Illinois, southeast Missouri, eastern Arkansas into this evening. And so we may see a little bit of a ramp up, maybe a few embedded circulations in the line. Storms will eventually congeal into a line. So that could help increase the low-level shear just a little bit as we go into the evening. But by then, the storm mode may be unfavorable. We'll talk about that in a second. Surface pattern here is kind of the same. Let me zoom in a little bit if I can on this sector here. So here we are at 12Z, just this broad cyclonic flow centered around that cold frontal boundary. Maybe a couple weak centers in here. Not a robust low-level response. We do see maybe a little bit of surface enhancement there in central to eastern Missouri going into the afternoon hours, but that could be convectively enhanced there. But we will have to watch that as the surface low. If we do get a little bit of weak cyclogenesis here along the cold frontal boundary, we could see winds back just out ahead of that. That could slightly enhance low-level shear and enhance the tornado threat up here, pending storm mode concerns. So the surface pattern here is just a little bit wonky with this event, and it's very unusual. You'd think given a strong trough, you'd see a little bit stronger low-level cyclogenesis. That's not the case with this event. So let's look at moisture here. Moisture is going to be critical today, as we talked about. So here is our initialization. We'll look at our 12Z initialization here from the NAM on the 6Z NAM. Has 60s dew points all the way up into southeast Kansas by 12Z, 7 a.m. If we were to look at our surface data, that is just simply not the case. This is 13Z, and you still see 60s are confined here to northeast Oklahoma, 65 at Tulsa, 61 at this particular station here, and it trails off going into Arkansas. That 60s dew point line somewhere in there. So based on what the NAM was showing, it had moisture all the way up here. So moisture is definitely a little bit behind schedule. This could be influenced by the outflow boundary keeping that moisture south, that lack of a robust surface response, not allowing that moisture to really surge northward into the region. So a little bit of a concern in interpreting these models at face value, the moisture is a little bit off here. As we go into the day, you'll notice that mixing on the NAM is not quite a concern. And that is usually the case. The NAM tends to not mix too much. Now let's shoot to the HRRR real quick. I know a lot of people like to use the HRRR. Here is the 12Z HRRR here. We go forward. Those 60s dew points handles the moisture a little bit better, has those 60s dew points still confined into northeast Oklahoma at this point. Gets into Missouri, but look what happens. It mixes out real bad there. Dew points, we see a plume of upper 60s dew point or lower 60s dew points here into southwest Missouri by about midday today, but then they really plummet into the mid to upper 50s here along that boundary. That is a classic HRRR over-mixing scenario, I think. The HRRR tends to have a bias toward over-mixing the moisture. So I think somewhere in between the HRRR and the NAM run is probably going to be what happens in reality. So the NAM has, low to mid 60s, 63, 65 in here by mid-afternoon. The HRRR has plummeted dew points in 55 to 58 or so across this region. So somewhere in the middle, 61, 62, we might see dew points drop a little bit into the low 60s across this area this afternoon. And then we'll again have to watch how this moisture evolves throughout the morning into the afternoon, how far north this gets. If it does get north, I think mixing will be a little bit of an issue, not nearly as much as the HRRR is showing, but something to keep in mind for sure as temperatures are expected. The NAM, of course, too cool. If we were to go to the HRRR here real quick, the HRRR has temperatures up into the 80s here, 80, 82 degrees here across this region. You take 82 over 62, for example. That is a 20-degree temperature dew point spread. That is really starting to get on the fringes, on the margins for tornadic activity in an already somewhat unfavorable environment for tornadoes. So we'll have to watch that mixing for sure. If temperatures do get a little bit higher into the low to mid 80s and dew points crash a little bit more into the low 60s, then we will see much more of a damaging wind and large hail threat. Still, this is somewhat favorable for tornadoes, at least the low-level thermodynamics there, but we'll have to watch that mixing for sure. So back to the NAM here. And so you see that moisture does get up to the north, a little bit farther north than the other models have. Let's take a look at the RAP real quick. And the RAP is over-mixing pretty badly as well. That is not really going to be the case today. So let's just look at the NAM here just for simplicity's sake. So by 18Z, we see storms probably start to fire here along this dry line cold front boundary as the trough moves in. We start to see that forcing increase, and we will see storm initiation fairly early on today, I think. There's our little wave there at 500 millibars, a little bit of stronger flow there. So I think storms will start to initiate across southwest Missouri, northwest Arkansas, perhaps far eastern Oklahoma, wherever that dry line boundary sets up, or cold front boundary sets up, will be our initiating boundary. You see it is somewhat progressive, moves off to the east fairly quickly, especially as that trough moves in. So given that this is fairly progressive, I do think storms will be fairly quick to transition to a more messy linear mode. Now let's look at our initiating boundary and our shear vectors with respect to the initiating boundary. So there is our frontal boundary right there. And let's look at our shear vectors with respect to that. Shear vectors, especially with northern extent, very much parallel to the boundary. A little bit more off the boundary here as you go farther south into southwest Missouri and western Arkansas. So that could favor a little bit more of a longer window for discrete storms. But again, given the progression and the progressive nature of the boundary, I do think we will see a fairly quick transition to a linear mode. Maybe a broken line initially, maybe some semi-discrete supercells in here. And that would favor a large hail threat before things transition to a damaging wind threat as that boundary moves off quickly to the east and storms will congeal along it. So let's take some soundings here. We will start at 18Z right out ahead. And again, keep in mind the moisture, the mixing concerns here, the drier air aloft, and that we may not see these low-level thermodynamics here at play. So this is at 18Z, a little bit of a capping inversion left. So still yet in the process of eroding, but quite a bit of instability throughout the profile, almost 3,000 joules per kilogram of mixed layer cape. Strong low-level instability despite this little inversion there, of almost 100 joules per kilogram of 0 to 3 kilometer cape. Pending this inversion, I do think temperatures will be a little bit warmer here. This is the NAM, always a little bit too cool. And again, the mixing is going to be a little bit of a thing to watch there. 64 degrees might not be that that high by this time today. 18Z is about 1 p.m. Central Daylight Time. But look at these photographs. Just not all that favorable for significant severe weather. Shear, effective bulk shear at 32 knots. That's very much on the margins for supercells. I do think we will see a few supercells out of this event, but low-level shear, very, very weak. Low-level winds are very veered, not much curvature there in the hodograph. So this would favor a large hail threat, definitely a large hail threat with very strong instability, steep lapse rates, and weak low-level shear with any sustained discrete or semi-discrete supercells. Large to very large hail is going to be a big threat today, especially in the initial stages of storm development. Let's go on to 21Z. We'll take one here up kind of near that developing surface low. We'll take one down here in southern Missouri, out ahead, and perhaps one down here into Arkansas where the moisture is a little bit better. Moisture is a little bit better with southern extent, but the low-level shear, the wind shear overall decreases with southern extent. So here it is at 21Z, east central Missouri. Little bit of curvature there in the low levels, about 130 meters squared per second squared of effective storm relative helicity. Bulk shear only about 32 knots or so. Again, that's very much on the margins for tornadic supercells, for supercells in general. Very small hodographs, but very strong instability, over 3,100 joules per kilogram of mixed layer cape. 0 to 3 kilometer cape as that cap erodes, very, very strong, 160 meters squared per second squared. So, or excuse me, joules per kilogram. So if you can find any boundaries today where surface vorticity is enhanced, that is going to be stretched into the vertical. That may enhance the tornado threat a little bit. Let's go back to our 0 to 3 kilometer cape and vorticity product. And this is based off of the RAP model. But you do see we have some of that vorticity along the boundary, along the cold front here. And as we go into the afternoon hours, let's go forward a few hours, a lot of surface vorticity there, and you do see some storms firing up there in southwest Missouri. So that could enhance the tornado threat, maybe along any outflow boundaries along that cold front. Could enhance tornado genesis a little bit, given very strong low-level instability, some strong vorticity along that boundary. And we could see maybe a little bit of an enhancement in tornado genesis, the ability for storms to undergo tornado genesis, despite weaker low-level shear. That strong low-level instability is very, very eye-catching. Once again, we will have to watch this, the temperature dew point spreads there with a little bit of mixing probably at play, perhaps getting a little bit warmer than this as well. So temperature dew point spreads may be on the margins for significant tornado activity. Down into southern Missouri, much of the same, a little bit worse low-level thermodynamics. That could be just a model quirk there. But the hodograph's much of the same. A little bit of low-level shear, a little bit of wonkiness there in the hodograph. And then into Arkansas, much of the same as well. Let's go to 0Z. So we should see storms congeal into a line, given, again, the progressive nature of this front. So let's take a few soundings out ahead of this frontal zone and the ongoing convection into Arkansas there. So this is Missouri. We do see some enhancement here in low-level shear ahead of that surface low. We did see on the NAM run in particular a little bit of an enhancement of low-level shear because of that surface low development up there in central to eastern Missouri. So that could enhance low-level shear. You do see a little bit more curvature in the hodographs here, a little bit more veering in those low-level winds with height. Which could foster a little bit of a greater tornado threat. Again, storm mode may keep that at bay. We could see some embedded circulations in the line up there. And with any semi-discrete supercell still left, that could foster an enhanced tornado threat as well. Down into Arkansas, not quite as strong low-level shear there. You do see effective shear has increased to about 50 knots or so there. So should favor some supercells, maybe some embedded supercells. But again, storm mode concerns should definitely be into a line at this point. We could see storms all the way back into the Arklatex, northeast Texas as well, that could have a large hail threat as well as some damaging winds there. So very interesting setup here. Let's look at some model data. Let's go to the 12Z HRRR run. I believe that is our only cam that is in yet from the morning runs. So let's look here. You see that convection, the convection ongoing in Missouri. Moves off quickly to the east, and it's replaced by convection later on. HRRR has been pretty consistent in firing some storms here right at that Missouri, Oklahoma, Kansas triple point there, near or just north or northwest of the Joplin area. Now these storms, this is at 18Z, this is 17Z here, so right about midday, 1 p.m. right here. So let's take a sounding here just to see, and again, I think the low-level shear is going to be fairly weak. Do see a little bit there, maybe low level shear though. If you look, 0 to 1 kilometer is fairly straight there in that low level photograph. So not much low level shear, low level curvature to speak of, but very strong instability by this point, with strong low level instability. So we will have to watch that for sure. And these storms again have been very consistent by the HRRR. We move on a little bit. And they do stay fairly discrete. A little bit more curvature here as we go on into the afternoon, but you'll notice the dew points definitely have cratered here. Again, this is the HRRR. 59 might be a little bit too much of that mixing taking place, but this would be an environment for some large hail, maybe a tornado or two, given such strong low-level instability, maybe some surface vorticity there in proximity to these storms. And then things are going to fill in pretty quickly as we go into the afternoon. Storms fire along that advancing cold front and quickly become pretty much a line of storms moving off to the east. Again, maybe enhanced tornado threat up here along the surface low, the weak surface low that develops along the cold front here in eastern Missouri. Some embedded circulations there in the line, as well as down to the south could be the exact same thing, transitioning to more of a damaging wind threat along the line. Maybe let's take a look quickly at last night's WRF runs here, just for giggles. You see that outflow boundary. The ARW has handled the morning convection pretty well, not quite as widespread as this, but it does have the boundary surging southeastward. There you see that fine line right in here. That is the outflow boundary modeled by this ARW run. So it fires storms here, southwest Missouri. Not very quick window for discrete storms too. And again, that could be some HRRR bias. The HRRR does tend to overdo the amount of discrete supercell development in severe storm environments. The ARW here has a pretty quick transition to a linear mode and a squall line here with more of a damaging wind threat. NSSL WRF from last night. Let's take a look real quick. Pretty good handle on things as well. Has that boundary surging south. You see again that fine line there. That is the outflow from the overnight storms surging southeastward. And then by midday, we do see maybe some semi-discrete elements there in the line. But by the next hour, this is 21Z 4 p.m., I think we will see storm development earlier than this today. But quick transition to a more linear organization to the storms. Maybe some semi-discrete storms up there into Missouri, but I think mostly we will see a more of a linearly organized complex there as it moves off to the east. So that's going to do it for this video. Again, a very interesting setup. Lots of subtle factors at play. Not quite the low-level response you'd expect to see with a trough like this. But we do have that outflow boundary in play we'll have to watch, and a lot of nuances to the setup that could make this a pretty favorable setup for maybe a few tornadoes, maybe not. Leaning toward not at this point. We'll have to watch how things progress throughout the day. I think the main threats, as the SPC has noted, are going to be large to very large hail, especially in the early portion of storm development here. Storms will fire again about midday or so, right about lunchtime or just after here in maybe western Missouri, southeast Kansas, far northeast Oklahoma, northwest Arkansas, and then quickly move off to the east. As long as they can stay semi-discrete, they will have a significant hail threat given very strong instability and fairly weak low-level shear, and a somewhat favorable mode for supercells. And then a quick transition to a linear mode. We should see a damaging wind threat take over as storms move off to the east. Again, a few tornadoes are possible, especially if that outflow boundary can stall here and retreat a little bit off to the north, becoming a little bit more stationary, and with any storm interactions that happen. But I don't think tornadoes are going to be a huge threat today. I think it's mostly going to be a large hail and then eventually a damaging wind threat for today's setup. So if you live in these areas, especially the orange area here, the enhanced risk level 3 out of 5, places like Jefferson City, Springfield, down toward Little Rock, Shreveport, definitely take things seriously today. All hazards are on the table, and we could see a pretty potent line of storms come through this afternoon into the evening. So with that, thanks for watching, and we'll see you in the next video.